Okay, so I think this is recording. Let's take a look at some of these mixture problems and see if I can't help a few people out. In most of these problems that we occur with our mixtures, we're going to be adding two ingredients to get a final mixture. So what I always do is use this picture to get a good visualization of what's going on with the problem. On the outside of the container, I put a label of the concentration, or if it's a dollar the unit cost in some of the ones with peanuts and different things that you sell. Now underneath there I usually put either the weight or the volume. So we know that each term in my equation is going to be a concentration times a volume, or a concentration times a weight, or some type of unit cost times a weight. So let's see what we can do with this problem in filling in information in our drawing. We have 8 kilograms of mixed nuts containing 25% peanuts. That's being mixed with 12 kilograms of another kind of mixed nuts that contains more peanut, 35%. So what peanuts are what percent of the new mixture? So we have this 25% peanuts, and we have 8 kilograms of it. That's its mass, its weight. All right, we have 35%, and we have 12 kilograms of it. We're going to dump these two nuts into a single container. That single container will have a mass, a weight of 20 kilograms. 8 kilograms plus another 12, it'll be 20 kilograms. Now the problem is asking me to determine the percent of this new mixture. The one thing that I know from this is that percent is going to be a number that's between 25 and 35. Okay. Now, and my final answer is going to be a decimal number, and to convert it to a percent, I'll move the decimal point over 2 places. So I'm going to take 25% written as a decimal times the weight. We're adding this other ingredient, 35%, 0.35 times the weight, and that's going to equal this x times 20, or we more commonly write it as 20x. Alright, so 0.25 is 1/4. 1/4 of 8 is 2. I'm going to use a calculator so I don't make a mistake. Well, if I can get the calculator to turn on. There we go. 0.35 times 12. 4.2. So on the left hand side we have 2 plus 4.2, so let's just add 2 to that, which we know is going to be 6.2, and let's divide by 20. So we know that x is equal to 0.31, and as a percent, we know that 31% is our final answer, that the new mixture is 31% peanuts. Yeah. Alright. I'll just write it right here. The new mixture is 31% peanuts. Alright. The next problem. Hopefully we'll recognize a common thread as a way to approach these problems each and every time. That's why I'm going to have this same drawing to try and get that same visualization. I'm going to mix two things together to get a final mixture. I've got 20 ounces of mixed nuts that's containing 50% peanuts, so that's what we're tracking, is the peanuts. This 20 ounces being mixed with 10 ounces of another kind of mixed nuts, and it has less peanut. It's got 20% peanuts. So again, it's asking me to determine the percent of this new mixture. So I have 50% of this 20 ounces. Half of it is peanuts and half of it is not peanut. 50% is peanuts, 50% is not peanuts. Now over here, of this mixture, which is 10 ounces, 20% is peanuts, so 80% is not peanuts. Now if I have 20 ounces and I add 10 ounces, I'm going to have 30 ounces. But I can't just immediately look at this and determine what the new percent is going to be. I'm going to have to see it in an equation. All right, so we do like we did last time. We're going to add up just the weight of the peanuts. So we've got 50% of 20, 20% of 10, and we've got 30 times x. All right, so half of 20 is 10. Multiplied by 10, and I'll move the decimal point over one place. Let's go to the calculator and see what 12 divided by 30 is. I divide both sides by the coefficient that's in front of x. So 12 divided by 30. Now, I'm expecting an answer that's between 20 and 50. If I've done everything correctly, there's no way that this percent is going to be less than 20 or greater than 50. Let's see what it is. I get 0.4. Now, written as a percent, that's 40% because I moved the decimal point over two places. So the new mixture is made up of 40% of peanuts. And that's all I wanted to know. I just took that 0.4, I took the decimal point and moved it over two places. All right, let's take a look at number 3. And again, we're trying to approach this in the same way each time. That way we know how to start these problems. We know that there's going to be these ingredients that we're mixing together, that we're putting them in one container for this final mixture. How many ounces of peanuts must Shrey add to 10 ounces of mixed nuts that contain 70% peanuts to make a mixture with 90% peanuts? So my final mixture is going to be very heavy in peanuts. It's almost all peanut. It's 90%. I've got a 70% container. I have a 10 ounces of nuts, of which 70% is peanuts. Now, when it says how many ounces of peanuts, so if this is peanuts, that's not a mixture. That's all peanuts. There's no other kind of nut in here. This is 100% peanuts. And how many ounces, that's going to be my variable x. So I have these pure peanuts that I'm adding to this 10 ounces at 70% to increase that concentration from 70 all the way up to 90. If I have x ounces plus 10 more ounces, I have a total volume or a total weight of x plus 10 ounces. Okay, so just like last time, we take the concentration times the weight. 100%, I move the decimal point over two places. That's just 1 times x. This 70% is 0.7 times 10. And here 0.9 times x plus 10. Alright, let's give myself a little bit of room. 1 times x, hey, that's just x. When I multiply this 0.70 by 10, it moves the decimal place over one place. So I can see that 0.7 times 10 is 7. Distribute this 0.90 to both terms. I'm going to go ahead and put a 1 there as a visual aid. 0.9 times 10. Well, multiplying by 10 is going to move that decimal place over. So that's 9. Alright, so let's collect our variables on the left-hand side. So let's subtract 0.9x from each side. And let's subtract 7 from each side. So on the right-hand side, these guys just cancel each other out. 9 minus 7 is 2. On the left-hand side, the 7 minus 7 cancels each other out. And 1 minus 0.9 is 0.1. So I divide by the number that's in front of x, or in other words, I'm going to multiply both sides by 10. If I multiply the left-hand side by 10, that'll move the decimal point over, and I'll have 1x, and I have to multiply the right-hand side by 10. So I'm getting that x is equal to 20. So is that what it wanted? How many ounces of peanuts? Shrey must add 20 ounces of peanuts. I don't know, to get the desired mix, to get the desired mixture. Something like that, just a brief sentence. Alright. So we know that this is 20 ounces, we know this is 30 ounces, and 20 plus 30 is 50 ounces in our final mix. Alright, so how many kilograms of peanuts? So again, we're adding pure peanuts. We don't know how many kilograms yet we're going to add. But this thing is all peanuts. And we're going to add 16 kilograms of this mixture that is pretty weak in peanuts, 15%. Now this 100% is going to raise that concentration, and in fact we're going to add enough that it raises it all the way to 60%. So now this new mixture, more than half of it is peanuts. If I have X kilograms plus 16 kilograms, I have a total weight of X plus 16 kilograms. So now I can set up an equation again by taking concentration times the mass times the weight. 100% written as a decimal number, 1.0 times X. 0.15 times 16. And over here, 0.6 times the quantity, x plus 16. So let's take a look at what we have here. On the left, I don't know what 15% of 16 is, so let's go to the calculator. 15% as a decimal is 0.15, 15% of 16. 2.4. Let's distribute the 0.6 to each term. 0.6 times x and 0.6 times 16. Well, it's going to be more than half of 16 is 8, so this is going to be a number that's larger than 8, 9.6. So now let's get the variables on one side and the constants on the other. So let's subtract 0.6 from each side. 1 minus 0.6 is 0.4. Let's subtract 2.4 from each side. 7.2. Let's divide each side by 0.4. and I do not know what that is, so I will go to the calculator. I've got 7.2 divided by 0.4, 18. All right, so let's see if this answer is reasonable. If we have this 15%, we have this 16 kilograms, and it's very little peanuts. We're trying to get it to be more than half, so we've got to add almost, well, we would add a little bit more than the 18 kilograms of pure peanuts will raise that concentration up to 60%. Seems reasonable to me. So I'm not sure how she pronounces her name, but Imana must add 18 kilograms of peanuts. Now, and sometimes people will even put pure peanuts to really emphasize that it's 100%. Must add 18 kilograms of peanuts to get the desired mixture. Alright, so I hope that helps. Let's take a look at number 5. Suma Lee made a nut mixture that contains 60% peanuts. So she's made this. How did she make it? Well, she added 12 kilograms and 18 kilograms together. So her final mixture over here is 30 kilograms. The 12 kilograms was 60% of peanuts. And the 18 kilograms was 42%. Let's make sure that I've set this up right. And I haven't. I've got this 60% here. Okay, I've made a mistake, so let's back up. I'm getting a little bit tired. When you get tired, you're more likely to make mistakes. The 60% was the final amount. That's the mixture that Suma Lee made. Mixing 12 kilograms that was 42% peanuts. So this 12 kilograms, I should have had it labeled 42%. And 18 kilograms of a different brand, I don't know the percent of this second brand. And in fact, it says the second brand of mixed nuts contain what percent of peanuts. That's going to be my variable, X percent. All right. So let's set up an equation. Sorry about that. But sometimes when you do make a mistake, you can learn from it, figure out what went wrong, and try not to make that mistake again. Let's take the concentration times the weight, 0.42 times 12, x times 18, or I'm going to write it as 18 times x, and 0.6 times 30. One equation, one unknown, we can solve for x. So let's solve for 18x by, let's multiply 0.6 times 3, probably 1.8, yeah. And let's subtract 0.42 times 12. We'll subtract 0.42 times 12. Okay. Let's pause this.